All right, reciprocals and rational functions. So generally they look something like this, linear function over linear function, although they could look like a lot of different things. Okay, first thing is to find the asymptotes. Now, we'll get a graph it. We'll have a quick look at what that looks like. There it is. So the asymptotes look to be maybe at y equals 2 and x is minus 1. So we're just going to put these in at maybe like a little guess here. But we want to show this algebraically. So the easier one to find is the vertical asymptote. So this happens when f of x is undefined. And that's going to happen when x plus 1 is 0. So the bottom of the fraction is 0. So x is minus 1. So cool, we got that one right. The horizontal asymptotes are a lot trickier to find. So there's sort of two methods you can use. I'm going to recommend polynomial division, so as long as you're comfortable with doing that, because if these get any more complicated than linear functions, it's a little bit nasty. 2x plus 3 over x plus 1, so we're going to put x plus 1 here, and we're going to put 2x plus 3 here. It's a very short division. You get 2 there. 2 into x plus 1 gives you 2x plus 2. So our remainder is subtract those away, you get 1. So therefore, 2x plus 3 over x plus 1 is the result 2 plus 1 over x plus 1. So that's how that division plays out. Now, basically, as x goes to plus or minus infinity, 1 over x plus 1 goes to 0. Now this is f of x, so I might actually just write this as f of x. So therefore f of x will go towards 2. Wonderful. So that's good. That's how we prove it using division. You can sort of do it using factorization, although I want you to be a bit careful with this method. So what you can do is you can start off with the original function. You can get 2x plus 3 on the top over x plus 1 on the bottom. Now we want a factor of x plus 1 over the top. So what you could do is you can write this as 2x plus 2 plus 1. So that's just breaking up the 3. And you get x plus 1. So you're going to get 2 brackets x plus 1 over x plus 1. And then that's 2 lots of x plus 1 over x plus 1 plus 1 over x plus 1. And then that gives us the same result as what we got before. So this is factorizing, I guess, only if you hate division. But the division method is preferred. Now, I'm going to tell you a sneaky trick. Now, this trick I like to call my cheeky limit theorem. It's actually this rule. L'Hopital's rule. I never know how to pronounce that name. But basically, if we are going to something like 0 over 0, so maybe if f of x goes to 0 over 0 as x goes to plus or minus infinity, then the limit as x goes to plus or minus infinity of f of x, yeah, I should also say f of x is some a of x over b of x. The limit is actually a dash of x over b dash of x. It's a very weird theorem. So the way that we apply that in this situation is we've got 2x plus 3 over x plus 1. So we're going to differentiate the top. So you get 2 and you get 1. So this is differentiating top and bottom. And so that limit is 2, which is also what we found here. Now, never use this. Like, this does not show it. You're not supposed to know this rule, but it's a really quick way to check. So if I had something like 3x plus 5 over 2x take 8 or something like that, I could say that goes to 3 over 2, and that's the limit. So you can see really quickly just by differentiating the top and the bottom. Now, this is not the full statement of L'Hopital's rule. It's a little bit more complex than this, but this is all you need to just double check these limits. Anyway, discuss the behavior of the graph near these asymptotes. So realistically, we can use our calculator now to help. So there's 4 things you need to discuss. So as x approaches -1 from the right, f of x goes up to positive infinity. So as we're coming in from the right-hand side to -1, it goes up. As x approaches -1 from the left, f of x goes to -infinity. So that's the vertical asymptote discussed. As x goes to infinity, it looks like y is coming down to 2. So f of x approaches 2 from above. And as x goes to -infinity, f of x goes to 2 from below, just like that. Okay, so that's good. We've done that. We need to find the axis intercepts now. So we'll do that. So to get the y-intercept, we need x is 0. So therefore, if we look at the original function, what is it? 2x plus 3 over x plus 1. So that's 2 lots of 0 plus 3 over 0 plus 1, which is 3. So that's the y-intercept. To get the x-intercept, we need y is 0. So 0 is 2 lots of x plus 3 over x plus 1. So you just set the top to 0. So 0 is 2x plus 3. So minus 3 is 2x. So x is minus 3 over 2, just like that. Now we can graph this, putting in all the really important bits. So we're going to put in that y-intercept. We're going to put in the x-intercept. We're going to put in the asymptotes. So that's going to be at x is -1. We'll just put that up there. And I'm going to put the other asymptote in at y is 2. So there's that one. Label your asymptotes. Y is 2. X is -1. We better put a scale on this thing. So nothing too strenuous. Just put 5 there. 5 there, -5 there, -5 there. And then we can draw a graph. So our graph will look something like this. Should be a bit steeper. And then something like that. So coming into 2 from above. And we can verify that just by looking at the graph here. And then we better label it. So f of x is 2x plus 3 over x plus 1. So that's a graph. Okay. Next, we got to try looking at a function and graphing 1 over that function. So these are little steps here. And it's best to think about what happens. So here, f is 0. So 1 over f is 1 over 0, which is undefined. So there, we're actually going to have an asymptote. And x is 0. All x-intercepts will become asymptotes for that same reason. So here, we're going to have x is 2 being an asymptote. Now, if f is positive, then 1 over f is still positive. So any positive or negative bits are still going to stay positive or negative. And then as this gets as small as possible, like local minimum, we're going to swap that for a local maximum. Also, any spots that you have it equaling 1, so there, for example, and there, our new graph is going to pass through that. Because also, if f is 1, then 1 over f also equals 1. You can see here, like, it's a half, so 1 over f should maybe be down here at -2. And then here it's getting really small. So it's really going to look to go up in that sort of shape. Let's see, it's about 1.2, so it's not going to come up too much above. It's going to hit a local maximum where that local minimum was. Cut back down through. Any points where the graph was at 1, 1 over f should also be at 1, or -1 in this case. So that's what that bit of the graph looks like. Here we've got a cross through, so there it is. We're going up to infinity, so if you ever go up to infinity on the original function, your new function should go down to 0. So we're actually going to be going out there. And then we've got this point here, so there it is. Similar sort of shape on the left here. So because the original graph was going out to infinity, 1 over f is going to go down to 0. So this graph here is 1 over f of x, and then the original graph was y is f of x. Now, in case you're curious, that's what the original graph looked like when I did it on Desmos. Okay, so if you ever have situations like this, where you've got an asymptote on the original graph, that original graph is y is f of x, asymptotes will become x-intercepts, so we've got an x-intercept there. And then we've got to look at these limits. So we got y is minus a half is the asymptote. So if we look at that, y is going to minus a half here. That means on our 1 over f function, so if f is minus a half, 1 over f is going to be minus 2. So I know that this one here will actually have to asymptote at minus 2, just like that. Okay, so let's see. I've drawn it on the wrong side of there. It should be coming down to minus 2, so just sitting a bit above that line. And then it's going to go up through this x-intercept. And any x-intercepts here will become asymptotes. So we've got this one coming down here. Y is minus 3. So x-intercepts and asymptotes need to swap with each other. Okay. Cool. So let's see if we can draw this shape. It's going to be very, very flat, coming all the way up through here. It's going to asymptote up towards this. Now I should make sure that any points where it's equal to 1, so that point there, for example, should pass through the same point, same as this point here. So those 2 points, those 3 points should be on the graph. If I want to draw this shape, it's very tricky to draw because of how flat this whole thing is. Something like that should be the shape down there. And then we want to shoot up to that asymptote. Then after the asymptote, because the graph is now negative, it's going to be negative. So it's negative, like very small number, which means that 1 over f is going to be a very big number. And we also need that at y equals 2. So let's see if we can get a shape like that. There it is. And that asymptote line at y equals 2 is going to go across the whole thing. I keep saying 2, but I mean minus 2. Okay. There's the answer in case you're curious. So something like that. So yeah, follow these steps to graph it. And that is a question you're very likely to be asked. Have a picture of f, you've got to sketch 1 over that function.